All right, Algebra 2, welcome to your applied lesson number 13. Remember, you will pause and copy all this information down on your odd pages. All right, so table of contents, we are adding in a new unit. We will be starting unit 4, so that's right down here. And you'll be adding things to page 39 and 41. All right, so the way I have this broken down, guys, is this is going to be how you set up page 41. So our learning targets to be able to solve complex equations using a variety of strategies. This is page 39. And the first thing you're going to put on page 29 is this information. So you're going to draw this out. All right, now that you've got this down, let's talk about what we have here. How many solutions does this have? Well, your solutions, as you guys learned before, I was going to try to drag these, but it's not letting me drag. So your solutions are your x-intercepts. They're your roots. It's where they touch the x-axis. So there are two solutions. And they show up where it touches the x-axis. So this is what we kind of covered already up to this point. So you can always solve your equations this way. All right, now this is the exact same graph, but instead of a y, we've made that y a 4. And so what we can do, guys, is there are a couple ways to solve this equation. So one way to do complex equations is to make two of them. So I've done this off to the right. We've got y equals 4. So the left side becomes y equals. And then the right side, y equals, and that should be a 3 here. That was a typo when I was writing that. And so when we graph them, you get the black graph's the parabola, and the blue line is the y equals 4. The intersections is where we look. And whatever those x values are, that is what x equals. So in this case, x equals -6 and x equals 0. And you can go plug them into that equation if you like and see that they work. So now what we're going to do is we're going to take this exact same equation and we're going to solve it algebraically. So we need to know how to do both. The graphic is a nice, quick, easy way to do it. Here's the way we do this algebraically. There are a couple techniques to this. I'm going to use what I think is the easiest one. I'm going to get the squared by itself. So I'm going to do +5 to both sides. We're going to get 9 equals x plus 3 to the second power. Now, just like how we can cancel a -5 by adding, we can cancel this squared by square rooting both sides. All right, now whenever you square root both sides, the side that doesn't have a square gets a plus and minus. So square root of 9 is going to be a plus and -3. This right side, the square root cancels the squared. So square roots cancel squares, exponents. Subtract 3 from both sides, and you get -3 plus or minus 3 equals x. So this means we got to do -3 plus 3 and -3 minus 3. That's 0 and -6. Those are the exact same answers we had when we did it graphically. What you have to remember when you do algebra, though, is whenever we square root both sides, the side without a squared gets a plus and minus. So you might want to jot that part down. All right, so now I want you to go to page 41. And now we're going to, it's basically the same type of learning target. We're going to do the same kind of pieces here. We're going to look at different ones. All right, so I want you to pause and jot all this down. what I've done is I've solved this algebraically. Green is the algebra. So let me draw a little line here. So in order to cancel a square root, we're going to square both sides. So that's what I did. I squared that square root of 2x plus 3 and that x. And the square cancels the square root, just like how in the prior problem. Just like how minus and subtract or cancels adding. So now you just got 2x plus 3 equals x squared. We do not introduce any plus or minuses here. Now this just becomes a regular quadratic. I can move everything to one side. So I had to take away the 2x and the 3. And I get x squared minus 2x minus 3 on the right. Now, there are two ways you can solve this. You can use the quadratic formula, or you can use factoring. We do the quadratic formula all the time, so that might be the way you end up doing it. I didn't have a lot of space in here, so I did it by factoring. So this becomes x minus 3x plus 1. And then what you do is you set each parentheses equal to 0. X minus 3 equals 0, x plus 1 equals 0, and I get 3 and negative 1 as my solutions. Here's the kicker. You don't put plus or minuses here, but whenever you do squares on both sides, you have to always check your answers. So I, on the left in the blue, plugged in the 3 into the x's, and it comes out to be 3 equals 3. So I know that that was a good answer. When I plugged negative 1 in, I ended up getting 1 equals negative 1. Well, that's not true. So x equals negative 1 actually was not a solution. So I come in at this point and I go, that is not an answer. And we're going to talk more about that in a minute. All right. Now, we took that exact same equation, but what I did is use what I talked about earlier. We can solve it graphically. So we do y equals the square root of 2x plus 3. That's the red graph. And then we do y equals x. That's the blue graph. And look where they crossed. At x equals 3. You can see they only cross one time. That x value is a point. So this shows you also that that negative 1 is not an answer. All right, last another bit here for this piece. We're going to talk about that number that doesn't work. It's called an extraneous solution. And it's an answer that you find when you solve algebraically square root problems. Sometimes they have them, sometimes they don't. That's why you got to test them. So on this problem here, I had to cancel that square root that the x plus 3 is under. So when I square both sides, this is going to give us a bunch of algebra. So you have to FOIL that 9 minus x, and you're going to have a lot of work to do. There's not a lot of space. But the answer comes out to x equals 6 and x equals 13. Well, look, let's test them out since we did this algebraically. When you plug the 6 in, you get 3 equals 3. And when you plug the 13 in, you get 4 equals negative 4. And that's not true. So that 13 is an extraneous solution, so we cross it out. So in purple on the left, I wrote down, always test for an extraneous solution when you square both sides. All right, so now what I did is I took that exact same problem and I did the graphic piece. I'm a really big fan of doing these things graphically because we have Desmos, man, and Desmos just rocks it. And that's what I did here. This is just a picture from Desmos. So I did y equals the square root of x plus 3, and then y equals 9 minus x. And you just look for where they cross. That x value is your solution. X equals 6. There you go. That's it. Man, let's use the technology. It's there. All right. And that wraps it up. So I forgot, once again, like I did last time, I forgot to put your homework assignment on here. Go ahead and check Canvas and get your assignments on Canvas. Hey, look, please bring questions to Zoom. All right, guys, take care. Stay safe.